When I say there's no time to explain, I mean it's literally because in a couple hours I'm gonna be going up to Maine to hike, so we just gotta make a tutorial in a couple hours. Let's do it. Now you're gonna notice that for all of these simulations, we're actually doing particle-based, so it actually looks like sand instead of silt fracture, meaning we're not gonna use the default particle stuff. You're gonna need to download and install the molecular script, which there's a link for in the description. Get that, and then we can actually start the tutorial. Okay, let me show you how to break some shit. We're gonna start off by opening up Blender, and while that opens, much more breathable now. Take the cube, bring it up. This is gonna be our particle stuff, the stuff that is gonna be broken. It can be any object. For the collider, we are gonna add in a plane, a big one, and make sure that this is a collision object, and make sure damping and friction is up so that our particles don't bounce everywhere. Back to the cube, go to the particle tab and add in particles because it's a particle simulation. I'm gonna have these particles only spawn on the first frame and last for the entire sequence, so we need to turn this into a grid of particles. So how do we do that? Go to source, go to faces, make it volume emission, and also grid, not random, grid. So now we can control the resolution of this simulation. Now take a object like a sphere, that's probably a simple one with low face counts, and we want this to be our particle instance. And just like that, we finished our particle simulation setup. You click play, it looks like garbage. How do we make it look better? With molecular. Take molecular and enable it. We're gonna simulate with a density of sand, I guess, since we want this to be a sandy looking simulation. You can use something else. For the collision type, we're gonna activate self collision, then you simulate, you hit the start simulation, and look at that. This is what I call a beautiful simulation. Now we just gotta contain it. So friction and damping, I'm just gonna use the numbers 0.2, 0.3. You can experiment with these, but I'm just gonna let you know these are numbers that work, but we don't have any clumping. It's like everyone is fending for itself. We want them to be able to attach together. To do this, go to linking, activate particle linking at birth, and we're gonna use a search radius of 3 because it's a number that works. You can experiment with this again. Broken 0.1 and randomness 0.15. We play the simulation, and now you can see that there are chunks that actually stay together. And once you're happy with whatever kind of simulation you have going on, just increase the resolution, simulate again, and you're gonna get finer and finer detail. Turns out I didn't really plan accordingly. I ran out of time, but if you want your texture to flow with your particles, make sure you click bake UV and then you simulate, and then all the UV data is stored in the the angular velocity attribute. Use that as a UV thing. You're done.